Now we go. Now we go. Finally. Thank you. All right. Tissues. And now it doesn't want to let me turn the daggum things here. Here we go. Why is it doing this today? If I start cussing, y'all just bear with me. Trying to get this thing to let me do what I want, how we've been doing it. All right, we'll just run it like this. So histology then is the study of tissues. I think we've already done that. A lot of us, everybody should be in lab. So a lot of this should not be rocket science, but then again, we should go over a lot of this. Okay, so histology then is the study of tissues. All right, come on, computer. All right, and we talked about the 4 major types, and we'll go back and they'll talk quite a bit about what's going on in the extracellular matrix outside the cell membrane. We talked about that, a lot going on there. And then our 4 major types of tissues, which would probably be a good short answer question, right? We've already talked about this in lab, are epithelium, connective, muscle, and nerve. We'll be looking at the connective tissue this morning in lab today. All right, now we already know the epithelium covers and lines all of the outside surfaces and all the tubes in the body. It is God's, I call it saran wrap. It lines everything, super important tissue. And specialized epithelium form our glands. Now that is a word that gets a lot of people thrown off here, but a gland is just simply a group of epithelial tissue that are modified to secrete a product. And these include things like sweat glands, salivary glands. Those are exocrine glands. And then we will look at the endocrine glands, which are the modified epithelium that produce hormones. Okay, so glands are a big deal, and I think that's going to come up again on slide in a little while. Connective tissues are going to hold everything together. If you remember from us talking about in lab, epithelium that we looked at today are very obvious. Muscle are also very obvious, and nerve tissue has a unique look. And so really, in my opinion, you have 3 main separate groups: epithelium, muscle, and nerve, and then everybody else gets chunked in connective tissue, which is what we're going to look at today in lab, hopefully. So anyway, epithelium, connective, muscle, and nerve, with a special note here that modified epithelium tissue can become a gland. Okay, the extracellular matrix, she's going to talk quite a bit about this. Ammerman does. I'm not going to go crazy about it, but there is a lot of stuff going on outside the cell membrane, outside these tissues. They produce a lot of times a compound called a ground substance. Like, for example, the gelatin type material in hyaline cartilage could be a ground substance. And a lot of protein fibers, okay, are present in this extracellular matrix. And if you'll take a look at the picture here in just a second, this is what's going on outside the cell. So this is where a lot of research is going on right now with all these different compounds outside the cell that are going to play a role in the function of the cell. And so that's what she's talking about here. I'm backing up here a little bit and looking at some of these. Some of this provides tensile strength to hold tissues together. Others serve as shock absorbers. Others, look at this. Some of this, just where we nutrients can be located, the intracellular there. Here's another one's kind of interesting here. This petroglycan is a protective layer.
Your screen's not shared with us, Mr. Robinson.
What now?
Your screen's not shared with us. We can't see it.
Okay. Don't know why. All right. One of those days, guys. One of those days. Just a minute. I'm going to share a screen. I don't know why it's not working here. Hang on. Just about to start throwing stuff. I'm probably going to cut the camera off here in a minute if I do, just because I don't want you to see what I'm doing. All right, here comes William. He was down here just a minute ago. Now that we got it working. Sorry, William. They got it. We got it. They all got in back door through through Zoom. Don't know why this is not working. Fully about to piss me off. Sorry, William. Long time no see.
Hello.
Trying to figure out why it won't let me share something here. So hang on. Trying to figure it out. All right, looks like I give one of y'all control of the screen for some reason. I don't know why. Is that working now? Can y'all see that? Thank you, sorry. Trying to get it where I can turn the freaking pages. It'd be nice if I could get this thing to work today. I am fighting it. It is giving me issues. I swear. All right, can y'all see it now? Hang on, I'm trying to get this thing to work. All right, why is it doing this damn stuff? All right. Someone's trying to get in now. Here we go. If I can figure out where that is. Hang on. All right. Trying to find the waiting room here. I'm having one of those wonderful days. They're just gonna have to wait. I don't know, guys. I'm having issues with this thing. All right. So can y'all see that now? Can you see it, guys? I'm sorry. Thank you. All right. I'm gonna just go through it. I'm not a big fan of extracellular matrix here, but just looking at some of the crap on the outside of the cell. Here's an interesting these chems, these cell adhesion molecules allow for our white blood cells to travel in the blood and hold on to the cell wall even against the flow of blood, and they're kind of interesting. This is kind of, you always wonder how a white blood cell can move against the flow of blood. Well, these allow them to stick to the surface of the cell. Anyway, we'll move on. This is what's out there on the outside. Now, also we see that there are like 3 types of fibers that are made by the connective tissue. And we're talking about here about connective tissue proper is the one that like this gets the cell called anyway that produces these. The 3 protein filaments that get chunked out here a lot of times. The collagen fibers, which are what give most of our connective tissues their strength. Really good one here. This is what you tear when you tear a ligament or tendon. Okay. It makes up about 20 to 25% of the proteins in your body. And then the next one here, now that the slide doesn't want to go, are elastic fibers, which are unique. They give the tissues elasticity. And we'll be seeing those in lab today with a slide of it by itself. And these are the ones that make your face pull back up. When you get old, you wear out the elastic fibers so you don't have the elasticity of our skin that we have when we're young. And then reticular fibers are one we're going to see in just a little while in lab that actually I think are kind of cool. They form a hairnet or mesh that allows the cells that forms a hairnet or a hammock to hold the cells in our connective tissues. So it's also kind of a very rare one. We actually have it in lab today as reticular connective tissue. Once again, these are extracellular, but also can be found inside the cell. Here's a couple of disorders of people that have a fiber, one of the protein fibers not making properly. Marfan syndrome is a disease where they don't make elastic fibers, leading usually to an aorta dissection. So that means the aorta ruptures and these people bleed to death. Pretty bad disease, can be tested for. Here's the next thing is looking at cell junctions, and this is one that's pretty common in all the ACT, a lot of the ACT type questions here. Is there 3 major junctions that hold cells together? In other words, why don't you fall apart into 100 million BBs or whatever? What makes the cells stick together? And these are called tight junctions, desmosomes, and gap junctions. Okay, are the 3 major junctions that hold things together, and they're going to be used in a lot of these integral proteins in the cell membrane. In the tight junction, look at this. These are found in the digestive tract and all the blood vessels. These seal the cells together so nothing can leak between them. Okay, and so what happens is adjacent cells right here have these integral proteins stick together like a zipper, and they go all the way down, up and down the cell. So the tight junction is our tightest junction, and it prevents any leakage of liquids out of a, for example, this could be where the food is at, out here, and it could be inside the cell, inside the tube. We got a few people coming in and out. Now bear with me. All right. So anyway, so tight junctions are pretty cool, where adjacent plasma proteins actually fuse together and form an impermeable membrane between the cells. A good example would have been in that simple columnar that we saw for the digestive system. Desmosomes, when they were first seen under electron microscope right here, they were actually called a spot weld. If you ever done any welding, they look like where if you ever tried to weld two pieces of metal together, they look very similar to this. And what it is actually, it is some of the proteins attached to the cytoskeleton, and it links the cells together. So it's a very powerful junction, okay, involving a lot of these intermediate filaments. Helps the tissues that are subjected to a lot of mechanical stress, like skin, but it's not waterproof. It's not, in other words, liquid can flow between the two cells. Almost what I see here are like the wire holding a light pole up, that ground it to that hold it up, like the guide wires connecting two cells together. So it's two adjacent cytoskeletons kind of fusing together. And then our third type is a very unique type. And this is where two tunnel-shaped proteins, integral proteins, fuse together to form a tunnel between two cells. And these are called gap junctions. So we have these small pores coming together, two tubes, like two straws coming together, and you have a tube that allows specifically ions to travel between the two cells. This is the one that, if you read your book carefully, the Amram refers to as electrical signal transduction, excuse me. So in the cardiac muscles, to get them to fire in rhythm, calcium ions travel through these tubes from cell to cell, and that's how we get that rhythmic contraction of the heart, which is kind of a big deal. So it is the exclusive property of these gap junctions to do this electrical transmission we'll talk about later in the muscle contraction chapter. Okay. They also occur in the brain to allow neurons to fire very quickly in the brain, but that is pretty rare, but yet they do exist. So it is a form of cell-to-cell communication. So these three junctions, well, there are three types of junctions holding anything together. One more time review: tight junctions, desmosomes, gap junctions are pretty cool. All right, now we're going to just dive through the tissues that we've already talked about in lab and the ones we're going to cover today and tomorrow. So now we have a nice little review of our tissues. All right, first of all, we've already beat this one in the ground. Epithelium, look at that. On every internal and external body surface, all tubing, all plumbing, its main function is a physical barrier between, to stop invaders. It is also a shield to prevent chemical, mechanical damage, somebody cutting you scratching something, or thermal injury from heat or cold. So when you burn yourself, first degree burn is only the epithelium, maybe. Okay, so those are very painful. But anyway, epithelium lines and covers everything. It can secrete, we've already mentioned that, and so they can produce glands, which are called endocrine and exocrine glands. We'll talk about in just a minute. So they can make hormones and other liquids like oils, like in our sweat, in our skin, and our hair. Selectively permeable membrane, doesn't let a lot of things in. And also the most receptors in the body, and we're talking about nerve receptors for touch, feel, temperature, etc., are found associated with the epithelium, usually right under it or embedded in it, okay? Including taste buds and all the, so most of our receptors are found associated with epithelium tissue. I like these little pictures that she had in the book here about, hey, it all looks pink. But we talked about this the other day. These were hard. Here is the basal membrane, and here's the epithelium above it. This is stratified squamous, looks like out of the esophagus. She talks about the dark purple circles are nucleuses, and you are seeing them stacking. So you just have to keep looking at this to get a feel for it. Okay. Here is another gland in the saliva glands right here, and that looks like that is one of the ones we don't do, the stratified columnar, I believe. Here is a blood vessel with red blood cells in it. There's simple squamous lining a blood vessel. So you'll see blood in some of these. Those are little blood vessels in the tissue. Okay, now if you notice this, most of these epithelium are going to have a lot of tight junctions because they're going to form a barrier to not let things seep in and out of the body or in and out of the lumen or tube that's carrying it. But usually you'll have an epithelium with a basal membrane holding it to the rest of the body. And we look for that a lot of times. And all epithelium have a open surface, not always to the outside of the air, but it could be to an inside opening. We saw that in the esophagus, the digestive system, right? We saw it lining the tubes of the kidney nephrons. So it usually lines a tube. It will have a layer of collagen fibers, reticular fiber under it. And here is an underlying connective tissue that holds epithelium to the body. So this is kind of what we're looking for when we look at these epithelium. Notice also that the epithelium is avascular. When you see the word a, and then once again, I'd like to slap some English people who come up with some of these dumb rules, right? But anytime you see the word a, it means not the next word. So vascular means to have lots of blood vessels. So avascular means it don't have any blood vessels. In other words, Robin is A tall, A cute, and A thin. That's all three not true, right? Okay, so you got to use the word A in front of that, right? But anyway, but it is kind of interesting. And because of this lack of blood vessels, it does limit its thickness. And actually in the skin, it's those outside cells that die lack of food that form that dead keratinized layer that we like to identify with the skin. We already mentioned that basal lamella and then a reticular lamella. Okay, we talked about a two-word name. First letter tells you the thickness of the cell. Simple, stratified, or pseudostratified were 3. Second word tells you the shape of the cell. Squamous, flat, cube, or columnar. Once again, we mentioned in lab that even though we're looking at a two-dimensional slice, that is a cube. If I tell you it's cube, or columnar, or pancake, flat. So one of those, you have to just get a feel for it. Like I said, they cover and line almost all of our membranes, right? They can have microvilli on them to increase surface area. We talked about that. Here, we looked at simple squamous, if y'all remember, on the glomerulus of the nephron. Here it is in the alveoli of the lungs. You're looking at side view of a fried egg. So this is the alveoli of the lung, single layer pancake cells, side view. Simple cuboidal, we saw, this is the slide we looked at, the tubules of the kidney, nephron, right? Simple cube. Concentrate, make urine. Here is simple columnar. Ours ain't quite this pretty. We looked at the intestine of the rat. Here it is, also a little bit associated with the respiratory system, but microvilli and cilia found in the respiratory of the pseudostratified columnar we looked at. There's pseudostratified columnar in the trachea and upper respiratory with the goblet cells producing mucus that lines the cilia to collect dirt particles to form boogers. One of my favorite tissues, right, that we don't talk about, kind of the redhead stepchild of biology, or when I talk about boogers, right? People don't like talking about boogers. Okay, we mentioned this earlier, I think in chapter 1, but there's a couple of ways things can be transported. Paracellular is when things are transported in and out of the body through in between the cells, okay? And then transcellular is when something is brought in, and we remember transcytosis was one of our mechanisms where something might be engulfed followed by exocytosis. I think it's actually on y'all's one of the terms on y'all's test. But those are several ways things can be brought in and out of the cell. Okay, then we saw stratified squamous. We looked at skin. This is keratinized. And you can see that dead stratum corneum outside layer. We're going to come back and probably tomorrow, may not get to it today, but we do have a chapter specifically on skin we'll talk about maybe today and for sure tomorrow. But stratified squamous keratinized is skin. And then non-keratinized, I showed y'all the esophagus in lab, but here is a picture out of her textbook of the vagina. So the vagina, anus, and mouth are stratified squamous, non-keratinized, and then the skin everywhere on the outside is keratinized, okay? So there we go, mouth, throat, esophagus, anus, vagina, kind of weird. Those are our non-keratinized stratified squamous. We looked at the esophagus in lab. Now, we do have a couple that are in the lab book, but I don't usually put on the midterm, but here's one of them, stratified cuboidal. There's 2 that we don't really do in lab, stratified cuboidal and stratified columnar. Here is stratified cuboidal, very rare, and I don't know if I see it, but I guess it's stratified cubes, right? Kind of a weird one. Lines the ducts of some of the sweat glands. So we'd have to look at the ducting. This is a sweat gland under the skin. Looks like a coiled snake of some sort. This is what it looks like. When we look at the slide, we can see the little circles shown here. Will not be on the lab test. Will be in the lecture test, okay? So I do have some matching tables, I believe, on the test. And now remember, we're going to do, quick review, we're going to do 4 and 5 today and tomorrow. Then we're going to have our midterm in lab on Thursday and lecture on a test, it's the chapter 7 that's not going to be on the test Friday. So our test, I believe, on Friday is 4 and 5, right? Which should be part of the easiest test of the year. And so that's going to be kind of a wild Thursday, Friday, right? Lab test on Thursday, lecture test on Friday. Then we'll come back and start bones, I believe, on next week in lab. That was William. Philip just came by, so we're all on the same path. If you're in Philip's class, y'all get the same thing I'm getting. I'm giving my lectures, my lab, so we should be on the same page. Here's the other one, stratified columnar. Another one weird. Look where this is found in the male urethra. I don't know why only the male urethra, cornea of the eye, and some of the salivary glands. But it's a stratified columnar. If you've been smoking some weed or something, I actually can't. I don't like to put these two on here because I've looked at the slides and I don't see it. These kind of run together to me. So that's why we don't do these. Most classes we didn't do these when I took histology. So, but anyway, these two could pop up in the verbiage of the test. I'm not going to have any pictures on our lecture test. Okay, that's what we're going to do in lab. We're going to identify these visually in lab, but not in lecture. So I might have a verbiage where stratified cuboidal found, something like that, stratified columnar, and you'd match it to one of those. Okay. Here is our transition. This is a much better picture than one I had in lab. This is the bladder. And you can see that it's kind of a stratified cuboidal or stratified marshmallow, and it can get thin or thick based on how full the bladder is. Also, also in the urethra. So we got the ureters, bladder, and urethra. It is a cuboidal stratified, but we call it transitional because it's God's stretchy epithelium. Once again, she does some excellent tables here, listing out a picture of it, its function, and where it's mainly found. So simple squamous usually lines vesicles that we need to get things in and out of the body. For example, the airways, right? Alveoli, and even in our blood vessels, all of our blood vessels are lined with a single layer of simple squamous epithelium. We'll find out later on in A&P2 that a lot of people have cardiovascular disease because these blood vessels are starting to peel, kind of like bad shingles on a roof. Or maybe they got bad. I always use a metaphor that some people will be overweight and eat terrible smoke and never get cardiovascular disease, and they got Michelin lining their simple squamous epithelium. And other people have O'Roy retreads. Does everybody know what a retread is? That's when they take a tire that's worn out and they glue new tread on. You do not want to go down I-55 doing 100 mile an hour on retreads, okay? You use them on a farm for old farm tractors and old wagons that you don't go real fast on, right? And so some people are just born with O'Roy retreads, and they're going to have issues, right, with their heart. Their blood vessels supplying blood to their heart. Other people have Michelin, really good tread wear on those epithelium. But a lot of research going into that simple squamous, trying to make it work better. Simple cuboidal, simple columnar, pseudostratified. We've already mentioned that, lining the passageways of the nose to filter out dirt. But once again, I'm not going to read all. We've done gone over these. Look at these tables, really nice. Okay, let's talk about glands. Glands are modified epithelium, which to me are very interesting, that are going to make some products. All of my grandparents are dead, man. My mom and dad are in their late 70s, 78, 77, 78, something like that. But my grandmother used to say, when she got sick, her glands is hurting. So every time I get to this word, I like to think about that. And I think for my grandmother, anything in her abdomen was a gland, okay? So let's do a better definition, right? A gland, and you do have a bunch of them in your abdomen, liver and pancreas and spleen, all these are glands, right? Or organs, let's say. But glands specifically are modified epithelial tissue that are going to make a product. And they come in two types, endocrine glands and exocrine glands. Okay, now here's the way you understand them. Endocrine glands always make hormones and put them in the bloodstream. So that is a very special group of epithelium tissue, modified epithelium tissue, that is going to make a hormone. And y'all remember us talking about hormones or chemicals that travel through the bloodstream, go to an organ, bind to them, and make them do something, or in a few cases, not do something they would normally do. And we talked about that, remember the first lecture, how LH causes the woman to ovulate on the 14th day of her cycle. Testosterone makes cells grow hair, men's cells grow hair. So one of the first chapters in A&P 2 is the endocrine chapter. Please remember that. Miss Dickens is going to go start that lecture off about glands, and you're going to look at her like, I've never heard of glands. What is she talking about? But we're spending 5 minutes right now talking about it in A&P 1. So glands are modified epithelium. Endocrine glands make a product called a hormone that's put in the bloodstream. It is a messenger, chemical messenger. Exocrine glands are the modified glands that secrete a product that is never a hormone, never a hormone. It is going to travel through a tube or a duct to an open surface. So exocrine glands make a product that's never a hormone that travels through a tube to an open surface, and a la sweat glands, salivary glands, all the glands that put the juices into our digestive tract. And so we'll look at some of those. Okay, so endocrine glands, hormones directly in the bloodstream. We got a whole chapter on endocrine glands. Exocrine glands put their product to an open surface. They can be multicellular, they can be unicellular. The goblet cell was an exocrine gland. It was a unicellular gland. Here he is. Here's the goblet cell in the simple columnar, making mucus, lining the digestive tract so you won't burn a hole in yourself, and the respiratory tract to stick dirt particles as you breathe in. Other exocrine glands are multicellular, and they're going to all have a tube or duct, and we actually name them based on the ducting. Okay, kind of wild. Now, I'm not going to go OCD on the test, but just check this out. It can be a simple single duct opening. It can be a compound branch gland. It can be the tubular shape, acinar, or tuboacinar. One tube, simple, bigger fat there, compound acinar, or even compound tuboacinar. So it can get real cray-cray, and these look really weird because you have to look under the epithelium in the skin. Okay, so I'm not going to make you know the ducting names, but that's kind of cool to me. If you took an advanced histology class, you'd spend a day looking at these glands, and specific, a lot of them in the skin, right, and the epithelium lining our body, or under the epithelium. Okay, a better way to look at them is the mechanism of how they secrete their product, okay? And here are 3 ways they can do that. Check this out. A myrican gland, used by the majority of exocrine glands, including salivary glands, makes a product, puts it in a secretory vesicle, and squirts it out by exocytosis. So this is the most obvious one, right? A product is made inside the epithelium cells. These look like simple cuboidals or something. They make the salivary saliva, squirt it through a duct opening into your mouth. You probably have got excited over food before and opened your mouth and squirted stuff out on the food, right? Which is a really great pickup line if you're ever on a date, girls or guys, right? To spit up on the food. But it is possible for you to open your mouth and saliva to squirt out of your mouth if you're really excited about the pizza, okay? But that's myrican, where it's an exocytosis. Now check out this next one. The holocrine, look at this, used by sebaceous glands in the skin and the oils of our hair. The whole cell ruptures and you get pieces of cell in the actual secretion. This is why the oil, the sebum of the oil in the hair is very thick, and milk kind of works like this too. So milk has part of mother's cells in it too. And that's why it has some immune function to it. Comes Rob. All right, they must have got it turned on. All right, here we go. Welcome, Roslyn. Yeah, we got the back door. Remember, I emailed y'all. Took me about 15, 20 minutes to figure it out too, because I had to start the meeting. But we probably need to make sure I've got that saved on my phone too, so I could have logged in from the house probably a little bit easier than I was trying to use the Northwest password to get in. So sorry about all our trouble today. All right, here we go. Back to our story here. Okay. And here's another one here. An apocrine is the third one, where it peaches off part of the cell. And this is the one that's mainly the breast milk. So in the breast milk, pieces of this epithelium cell pinch off. Holocrine, the whole cell, this is part of the excretion. And then myrican is just an exocytosis of the chemical. So myrican, holocrine, that's kind of a wild one where the whole cell ruptures out. And then apricot, it's just pieces of it tip off. And we didn't get a picture of that one. Okay. I give you one quick guess. Guess what the most common type of cancer is? Skin cancer or epithelium cancer. So epithelium is the most common type because, I mean, that's our first layer of defense, right? In all of our tubing, all of our external, the first layer of defense is epithelium. So it's very common. Carcinogens are things that cause cancer. And when you see the word carcinoma, that is a term for epithelium cancer. Okay? Have a wild one there. Here is a picture. Some of y'all may want to be a histologist or a cytotechnologist or a lab tech. Here is cancer in basal cell carcinoma, skin cancer. You can see the tumor cells that do not look normal under this stratified squamous skin. Okay, pretty cool. All right, now this is getting into what we're going to talk about today. So wake everybody up because this is what we got to cover today and tomorrow, the next couple. Okay, so connective tissues, and I'm not going to go into this too much about connective specialized or proper or whatever. I'm just going to kind of run through them. But in general, this is a group that holds a whole bunch of stuff in it that sometimes don't seem like they go together. So I think the overlying thing here would be to remember that they hold things together or allow things to, a lot of them are involved in binding. Okay, so we're going to see they can be binding, connect things together. They can be support like cartilage and adipose. They can be protective. Okay, and we'll talk about that. So these have play a big role in protection. I'll give you a good one here in a minute on fat protection. And then they're going, the blood transports everything through the body. So blood is thrown in this group. Okay, most of them have an extracellular matrix, right, where they produce a product. Like the cells that make cartilage make a jello-like material. You'll feel the end of your nose that is cartilage. Okay, so we're going to see that. And they're pretty widely found out throughout the body. A lot of times they will have one of these cells, and look at the score of these cells. These are some of the cells that are found as resident cells in the connective tissue. The first one I was trying to remember earlier, and I forgot about it, a fibroblast. That is the cell that makes these fibers I was talking about earlier. They make the collagen, the elastin, and the reticular fibers. We'll see them in lab today. Adipocyte cells are fat cells that are just, that's the name for a fat cell. That's very common in all of our tissues. Okay, now the next two are kind of interesting. Let's skip that one and let's go to phagocytes. Phagocytic cells are cells that are blood cells that have left the blood to go out and live in the connective tissues. Okay, and the most famous one, and we're going to do blood today too, so it's going to be pretty wild live today. But we're going to find out that there are only 7 things you need to know in blood, and there are only 5 white blood cells. The most common white blood cell is neutrophils, and they are bacteria eaters. The rarest is the basophil, which is a blood cell that has a big blue cytoplasm in it, and it produces histamines and heparin. And so the rarest blood cell is the basophil. The second most rarest is, my story straight here. Actually, scratch that. But the rarest is the basophil, which when it leaves the blood and goes to live in the connective tissues is this mast cell. So very weird terminology here. So let's make a mental note of this. A mast cell is a basophil that has left the blood and has gone to live in the connective tissues. Okay, bad metaphor here. Bruce Wayne is Batman. Clark Kent is Superman. Basophil is mast cell. Okay, very important to know that. Its function is to release histamines and heparin. Heparin makes you bleed when you cut yourself, and histamines cause inflammation. I took an antihistamine this morning so that the basophils in my nose would not attack all the plant pollen I breathed while walking into the building a while ago. Okay, so most of us maybe take an antihistamine to knock out this inflammation, which is part of our defense mechanism. Okay, now I was going to say the next rarest and that's why I corrected myself, is an eosinophil. But the third most common or third rarest, however you want to play it, white blood cell is this great big one called a monocyte, which we'll see today in lab. I call him Shoney's big boy. He's the biggest blood cell. He also can leave the blood and go out and live in the tissues and form what's called a macrophage. So you're going to be reading through this book and you go, all of a sudden she's going to say macrophage. You're like, what the heck's that? Well, that's a monocyte that left the blood to go live in the connective tissues. Now, if you'll stop just a second, I apologize. It's been a really technology crappy morning, things ain't working right. But listen to me. Simple squamous, stratified squamous is the line, is your skin, stratified squamous. Right under the stratified squamous is connective tissues. These monocytes leave the blood and go live right under the epithelium because that's going to be the first place bacteria are going to get in after you have an infection that gets through your epithelium. Does that make sense? So these are like layers of defense, right? And so these macrophages and mast cells that were formerly white blood cells called the basophil monocyte leave the blood and go hang out kind of like a check post or a guard watching over their post in the army. And these guys are really important, okay? Long story short, but we can see these a lot of times in the blood, or excuse me, in the connective tissue, these cells. And then to make it even more fun, other immune cells that she's not even gonna list now, okay? Now here is one of our first ones we're going to look at. If you'll look here, you can see at this arrow is pointing to the fibroblast, and this is the one that makes the fibers, right? That makes a big part of the ground substance. And this is the excretion that these cells make that form that connective tissue. To make that, for example, osteocytes make bone. Bone is the hard substance, is the ground substance of bone, and this jello type material that we know of as cartilage is the ground substance of the cartilage cells. So anyway, that's the fibroblast there. Here is adipocyte cell. And this is also a slide we're going to look at in a little while called fat. This is a slide, adipocyte cells. These are some of the cells we can see. Here's that mast cell that I said it makes histamines and heparin. Okay, and it plays a role. This is the basophil that left the blood to go live in the tissues. And here is that macrophage I just mentioned about, which is a monocyte that has left the blood to go into the tissues. Here is a macrophage eating 5 or 6 bacteria. One of my favorite pictures in the book. So see, he's got the little tentacles grabbing the bacteria, and he's going to endocytose them and kill them. So you have a tremendous number of this is the one that leaves the blood, but the most common white blood cells is neutrophil, which is also phagocytic cell, and they literally engulf and eat bacteria. We determine if you have a bacterial infection by doing a differential blood cell count and counting your neutrophils. If your neutrophil count is high, you have a bacterial infection. Very, very cool. So long story short, or short story long, you have millions of these cells floating through your blood, defending your body, eating anything that's not Robin, anything that's not Heather, anything that's not Simone, and they just engulf them. I seen a picture one time of one of these guys trying to eat asbestos, and they will eat themselves till they die. Pretty wild. Pretty fascinating cells. Okay, now we're going to kind of run through them, the main group here. Okay, we're going to walk through them. These are what they call connective tissue. Probably these are the ones that we've been talking about. The first one is loose connective tissue, and here it is. It's very loose looking, very unorganized. You can see that it is, first of all, the main thing to look for is look for randomness. Now, one of the weirdest pictures in the book is right over here to your left. Look at this. This is like the arm with the epithelium skin off. So here is the epithelium, and here we're going to skin it off. So this is right under epithelium. This one is found under all the epithelium in your body. So this is the one that holds epithelium to the rest of your body. You can see that it has collagen fibers, the dark red ones, are light red, and that gives it strength. It has some elastic fibers in here, fibroblast cells making some fibers, and then it has a ground substance in there. You might see a basophil in here, mast cell, or neutrophil also, not in this picture. So loose connective is God's stickum. It holds epithelium to the rest of the body. Okay. Then we have dense regular connective tissue, or dense fibers. I call it dense regular. And then we have dense irregular. We have 2 of these, so dense regular and dense irregular. Okay. Now I believe the first one here is dense irregular, and this is the tissue right under the epithelium. So look at this picture. Here is the skin, epithelium. There's the loose connective, and right under loose connective is dense irregular. It looks like swirls, and I actually see this as, I'll show it to you in lab, but this looks like side view of sushi to me. So it's dense irregular, forming the dermis of the skin. And then dense regular is ligaments and tendons. Look at this dude's hand. So these are tendons and ligaments. I will not make you know difference between ligaments and tendons in lab, but look how tightly packed these cells are. I think we actually use this word wrong. Okay, now let's pick on somebody in class. Faith has been doing pretty good. She's pretty smart, I believe. What if I said Faith was dense? That would make somebody mad. I think our slang language in America would say that she's kind of dense, is consumed. If you say some Robin was dense, he's kind of an airhead, right? Actually, I just said Faith is real well put, as her brain is well put together, very packed, very organized. Dense means, think about it, the population of people in Memphis is dense. The population of people in North Dakota is not dense, right? Dense means a lot of folks real tight. So dense means tight. Loose would be not tight. Dense, irregular, not quite too tight, and then very untight. So sardines in a can are densely packed. Faith, and I'm just picking on you, Faith. Not, you know that. Okay. So ligaments and tendons are dense connective tissue. So has anybody here torn a ligament or tendon yet? Anybody? Okay, you torn that. That's what you torn there, Olivia. So that is not, it does not heal very well. And the older you get, the less it likes to heal. When you see these athletes like Kobe Bryant, broke his Achilles tendon, that was really bad late in his career, and he made a comeback. I didn't even like him as a basketball player until he made his comeback, because he always was a Grizzly killer. So he always beat up on my Memphis Grizzlies. But I had a lot of respect for him after he come back from that Achilles tendon injury, which is usually career ending. Kind of liked him later in his career. Of course, he died. That was terrible. So dense, regular. That was those. And now let's do some random ones here. Here's elastic connective. So here's one that has lots of elastic fibers in it. And this is the aorta. So that makes up the tissues of the aorta. So it gives a maximum elasticity. So we'll look at this one today. Elastic connective is fairly easy. And so here we go. Here they are, kind of summary. So we had the dense irregular, dense regular, dense irregular, and then elastic connective. And then the next one is reticular. Now this is one I told y'all, those reticular fibers form a hairnet or mesh. And we're going to look at this in the spleen and lymph node. Now, I actually ordered these slides several years ago, and you should see a hairnet. Well, you can't see it here because in this slide that I've got, the hairnet is holding the cells. Can everybody see the little circles in this picture? Those are all white blood cells sitting in a hairnet or hammock or mesh. Okay? And so reticular fibers form the mesh. And so when you see a bunch of dots on my slide in lab, what am I showing you? Reticular connective. Those are all white blood cells sitting in the net. And so our lymph nodes are little filters for the lymphatic tissue, and we run it through, and then these cells eat the bacteria out of it and the pathogens. If you put on your imagination sunglasses and see those purple lines, there is a net in there, and you can see it as the green, not purple over here, but green on the left, and I don't know, dark over here. So the reticular fibers are forming a hairnet. Okay? Adipose cells, fat storage, insulation, socket absorbers, and protection. Here is the skin under the dense irregular. You get a layer of adipose that separates the dermis and subcutaneous layer of the skin. A couple of interesting. I got to tell an interesting adipose story. I actually had something I wanted y'all to think about. A friend of mine, a pretty good friend of mine when he was a kid, but he's grown now. Was in the youth group here. I've been in St. over 29 years, going to the same church. But he was in a tragic car wreck on Saturday night, right out at Thigh Tower, right by the Thigh Tower Church out there, out at Thigh Tower, right in front of the Thigh Tower Church of Christ. He was driving his vehicle with 3 small children, 2, 4, and 6, or 2, 4, 8, 3 little boys, his 3 sons, and was hit on by a drunk driver doing 60 or 70 miles an hour. My friend, young man, he's in maybe early 30s. He is in the airlifted him the med. He is actually doing better than the 3 children. The baby child had a lacerated diaphragm and colon, and they've done the surgery on that. And he had fever last night, and they put him back in intensive care. And so the seatbelts and all, and the kids were strapped in, literally saved their life, but it literally ripped them apart too. So all that damage was the impact trying to stop. It happened right in front of a friend of mine's house who's a Northwest instructor, who luckily is a social science instructor, a psychiatrist. She's a counselor. And she literally talk to those 3 boys and talk to them until the ambulance got there, and she actually flagged other cars down to help. Okay, so pray for that family if you don't mind. Caleb's his name and his family. But this is a story from another friend of mine that actually happened at my church here about 20 years ago, and actually it's kind of sad because this friend of mine, she just passed away. So this is a story about a friend of mine. But this actually happened in Senatobia about 20 years ago, before we had cell phones. I'd gone home. I'd gone to Tupelo. My family's in Tupelo. We'd gone home for the weekend. And so this happened. I wasn't at church this Sunday. But we actually we let church out, and one of my members, a friend of mine, was going to the car with her husband, and an old lady that should not be driving backed over her and ran over her. And this was actually the last time that woman ever drove. But she had dementia, but she actually ran over my friend and was backing over her, and heard her screaming and stopped and opened the door. And they said her face was almost right under the door. And so they were hollering, screaming. And so some men and women did a citizen's arrest and kind of pulled that woman out, because she was about to pull off of her. Don't put it in drive, going to pull off of her. And that was not good. And so they stopped it. And the way I understand it, a bunch of people got out there and it was a light front wheel drive vehicle. If it'd been like a big SUV, it would have probably could have killed her. But she was run over in the parking lot. They got her and picked it up, and pulled her out. And when we got home that 4 or 5 o'clock that Sunday afternoon, we had a voicemail on everybody used to have those old tape recorder voice machines, right? Answer machine. And mine said, like, click, click, we will not be having church tonight. We're having a special prayer visual for Sister Sue. I changed the name to protect the innocent. So I get to church, and you understand, she got run over in the parking lot. I mean, literally rolled over, run over, airlifted to the med. We're having a prayer visual. And I remember us all in there praying, and I heard the phone ring down the office, and somebody run down, answer the phone, one of our deacons or elders, and they run back in the sanctuary and they scream, "It's a miracle. Sister Sue has no internal damage to any of her organs." Okay? And it's one of those, and I really do think I've seen some miracles before with people that got real sick and they lived longer than they should. And I won't get into all those days. But this is one of those cold chills. Everybody's screaming, and somebody up front hollers, miracle. Somebody hollered Jesus, and I hollered obesity. I almost got thrown out of church. She weighed about 300 pounds. If it'd been Heather, we'd had a funeral. If it'd been Megan, we'd had a funeral. Those little boys yesterday are so thin they got hurt. But if they'd been Robin size, they'd been jumbo, let me tell you something. Fat is protection. That woman only had a little bit of knee injury. She had to have her knee worked on. So we like to pick on people that are overweight. But if you're in a bad car wreck, you want to be Pillsbury Doughboy. You don't want to be anorexic Ann. Okay, you don't want to weigh 100 pounds in a car wreck. But she lived another 25 years and actually had some other issues that came up later in her life. But she had that lady just passed away recently, a good friend of mine. But anyway, isn't that something though? But so obesity can have its advantages. I had my uncle when I was growing up in Lee County. My uncle was the sheriff of the county, and this whole things going on right now in our world. I guess I had a whole different perspective of police, because the police in my little town was my uncle, so he was a really good guy, I thought, and I think he was a pretty good man. But he told me one time he went to a bar fight where a dude pulled a pistol out and shot a fat man in the stomach, and it just stuck in it. It was like a 22 caliber, and he took the pistol and almost killed the guy. I mean, I talk about the guy that got shot, and he ended up going to prison for beating a guy with a pistol that shot him. He did not have a good lawyer, but that guy ended up getting like 10 or 15 years for beating a guy to death with a pistol that he shot him with. Got to think a better lawyer would have got that guy off, right? But I guess after the 12th time he hit him over the head with a hammer, with a handle, it was time to stop beating the guy. So anyway, won't do many more. I try not to do many gun metaphors. I prefer larger caliber than 22 personally. Okay, but like I said, my childhood. You get a gun for Christmas. That's what you got for Christmas. I probably have way too many firearms. Okay. Anyway, another story, but true story. So adipose is food storage, right? Energy storage. And one of the things that irritated me in the old book, it said that everybody 5'5" has the same number of fat cells. It's just how much fat you got in the cell. And it's really easy to put it in. It's hard to get it out. Gee whiz, I never thought of that. Okay. But if you ever try to lose weight, it can be discouraging. But anyway, we'll talk more. Adipose looks like broken windshield to me. Okay. There's white adipose and brown adipose. And we'll talk about that later. That brown adipose is a little bit more has a little bit more warmth to it. Obesity then is too much of this, right? Or the too much fat in the cells. All right, other ones here. Cartilage is a cool one. Let's do cartilages. Cartilages is very weird to me. It has, I'm going to get the picture of it. There are 3 types. Okay, you have hyaline cartilage, and this is hyaline cartilage. We're going to look at this in the trachea. And what I see here is Swiss cheese. If you'll notice, the cells are called chondrocytes, and they live in a little hole called the lacuna. Okay, so when you make these slices of the trachea, a lot of times the cell falls out like this, you just get a hole. That hole is called the lacuna. The cells living in the lacuna are called chondrocytes, and they excrete this matrix that feels like Jello. Matter of fact, if you rub the tip of your nose, everybody do that real quick. That's what Jello feels like, right? Matter of fact, that's the same stuff. That's hyaline cartilage right there. And the main protein in this is gelatin. Okay, so I think I usually tell this in lab. I'll tell it in class today. That guess what gelatin is? Diluted nose, hoofs, and ears. So if you like gelatin, don't keep eating it, but it's made from the bone and the cartilage at a slaughterhouse that's been boiled afterwards, and that clear protein gelatin is then diluted and given an artificial color and flavoring to make grape jello or strawberry or cherry jello. So you're eating diluted nose, hoofs, and ears, etc. So hyaline cartilage has no fibers in it. And the way I see these, the other 2 are fiber cartilage and elastic cartilage. So I kind of think of it like this. This is cheese pizza, right? And some people like pepperonis and some people like sausage, right? So you have hyaline cartilage with dense, regular connective tissue sticking through it to make fiber cartilage. If you look here, you can see the chondrocytes, and the swirls are ligaments and tendons running together. So fiber cartilage is hyaline cartilage mixed with ligaments and tendons, and that's what holds your intervertebral disc in. If you've ever had a slipped disc, then you may have torn some of this fiber cartilage, right? The actual disc, that is fiber cartilage is the intervertebral disc, but it has the ligaments to hold it in place. And then elastic fiber found in the ear and in the epiglottis here, but this is hyaline cartilage with elastic fibers in it so that the ear bounces back. So look at that. That's elastic. This is hyaline. How many of y'all broke your nose? Anybody ever break their nose? One? Okay, Logan, anybody else? All right, good. I asked that one time in a lab of 20, and I had 12 girls that had broken their nose. I'd never had a more violent group of women in a lab. And I think of those 12, like 9 of them had been in a fight with another girl over a boy. So it was a real violent group of women, okay? But if you ever broke your nose, it is laying the angle it gets hit. It does not bounce back. This is hyaline. Elastic makes it bounce back, so you have elasticity. So elastic cartilage on the screen. Fiber cartilage is dense, regular ligaments and tendons running through hyaline cartilage. A lot of times the chondrocytes line up a little bit. We'll see that in lab. And then regular hyaline cartilage has no fibers in the matrix. Okay. In lab, I talk about the 3 brothers or 3 cousins, right? 3 types of cartilage: hyaline cartilage, fiber cartilage, elastic cartilage. And I think we'll look at our lab pictures a little bit different than these. Okay, and then specialized include bone. We've got a whole chapter looking at bone. Bone is 35% collagen, 65% calcium phosphate crystals. So it has both protein, collagen fibers, and these calcium phosphates. Here's what it looks like. The cells that make bone are osteoclast and the osteoblast, excuse me, and osteoclast break them down. Very weird definition here. Another one that I'd like to slap somebody on when I jump too far ahead. But check this out. Osteoblasts are bone building cells. Now, everybody in this room knows if you blast your house, what have you done? You blew it up. But not in bone. Osteoblasts are the bone building cells. Osteoclast are the bone breaking down cells. And a mature bone living in its lacuna is called an osteocyte. So there's your 3 words. You know, we're going to see these on the test, at least this next test or the next one on bones. Osteoclast, break bones down. Osteoblast, build them up. I apologize for the stupidity of those definitions. And a mature cell is called an osteocyte. Here is bone on your left. This is what it looks like on the slide when you cut a bone and let it dry out. On the right is a slide of living bone with an osteoclast. Right here, breaking bone down. Osteocyte living in a lacuna. And here's osteoblast here, building bone. So you're always building and recycling your bones. I think about every 5-6 years that your bones are completely rebuilt and regrown. So you're always breaking them down. So if you're going to break a bone, it'd be much better to break it as a young person because it will heal quicker because you're in a growth stage. If you're an old person like me, one of my 57-year-old friends broke a wrist the other day, and they did a cast for like 2 weeks and it never did heal. So they had to surgically connect the bones back together to get it to heal and put it in another cast. And then we didn't know what to do with blood, so we chunked it in here. We were just at a loss. Blood is a connective tissue, for lack of where else to put it. Okay. There's a whole chapter in blood in A&P2. For lab today, if you have your whole lab book, that'd probably be a good idea because we may flip over to look at blood cells in the chapter on blood. In my lab, I cover it twice. I cover it thoroughly today, and then we cover it again in A&P2 because I don't think that there's many chapters more important than blood, right? I mean, blood's a big deal. You're going to be dealing with that in the hospital. Most of y'all are going to be working in a hospital. You might as well put that to long-term memory. There are two main components of blood. There is the plasma, which is the water part, and then there are the cellular part. So plasma is the liquid part, the solvent, okay? And in the solvent is plasma proteins, and then red blood cells and white blood cells are the two main cellular parts. And then there is this weird compound substance called platelets, which are considered cellular fragments. And we'll see that platelets play a role in stopping blood loss, okay? We'll talk about that later on, but platelets we'll identify. So today we will identify 7 things in blood: blood cells, platelets, and 5 white blood cells today. And we'll look at them in lab. Here is a picture with 3 of them: red blood cells, platelets, and 3 white blood cells. There's your neutrophil, the most common. Here is the lymphocyte, the second most common. And then the eosinophil, which is the 4th most common, or second rarest. It has a red crystals in it. This guy right here is your immune system. Lymphocytes are your B and T cells. AIDS kills one of those cells, which is a way to kind of remember that. So here's a cool picture of blood. Okay, other couple of random terms here. Osteoarthritis is something I'm dealing with, and that is when you wear a cartilage out. You wear a joint out. I have osteoarthritis in my right knee where I have no cartilage on the outside. There are 2 places where the condyles touch, and on the outside, I need a partial knee replacement. There are some chemicals that maybe y'all can start drinking now or eating these pills. Glucosamine is one that helps regrow that. It would be like putting a glass of water on a 5-alarm fire at this point for me, but maybe if Claudia or you young ladies started doing this, you might have a little bit better chance with your joints as you get older. But that's one you might find interesting. Here is a normal cartilage on the left, and here is osteoarthritis. So osteoarthritis is a destruction of the cartilage due to wear and tear, or maybe even due to bad genetics, and you have a bad knee design, and your knee is not properly designed, or your ankles are not right. You can see it's tearing it apart. So in summary, here we got them all here: loose connective, dense irregular, dense regular, elastic connective, reticular connective, and adipose. Great summary tables here. Cartilages are hyaline, fiber cartilage, and elastic cartilage. We'll see all those in lab today. Bone and blood, and we'll learn blood a little bit deeper than here. And I did run off the review sheet yesterday before I left, so I'll bring those to lab. All right, now our next one is muscle, which we'll do tomorrow in lab. We're gonna do muscle and nerve together. I find muscle will be a little bit easier. Muscles come in 3 flavors. Okay, all 3 involved in movement. They can be striated, meaning they have these stripes on them, or they can be smooth. The 3 are skeletal, cardiac, and smooth. Skeletal, cardiac, and smooth. Or as I like to call it, steak, hot dog, and chitlin. So chitlins is smooth muscle off the digestive tract that we like to eat. Cardiac muscle is almost exclusively used to make hot dogs. And I'm talking about the high-end hot dogs. When we cut the heart in A&P2, I want y'all to remember this moment. And when you cut it open, you're going to start singing, "I wish there was an Oscar Mayer winner." It's got that red off hot dog look. Okay, so it is cow and pig heart ground up, and steak is skeletal muscle. Okay. And hamburger meats is a skeletal muscle, just all ground up with all the muscles in the body. Okay. Now let's look at these. Okay, skeletal. Oh, now my thing don't want to move. I love how this thing acts up. Skeletal muscle are those that you have conscious control over. Our entire legal system in America is based upon skeletal muscle. Okay. In other words, it is conscious control. So if Cheney kills her boyfriend, she will go serve. She'll be arrested and go to jail, and we'll have a jury of her peers because skeletal muscle cannot move without you consciously deciding to do that. Okay. So our whole legal system is based upon the fact that skeletal muscle is conscious control. It is striated. It is multinucleated, and it's quite pretty. And here's a picture of it. Here's a drawing, and here's what really pretty. Here are 3 cells of skeletal muscle. 1, 2, 3. And these cross striations, we're going to see those red stripes. We'll see in a little while are actin and myosin lining up to contract. All muscles can do is shorten. Probably one of the most bizarre things I'm going to tell you this week is that no muscles push out. All movement is a contraction of a muscle. Okay, now watch this. So to pick that finger up, I contract these muscles. To straighten it out, I contract these over here. So biceps, triceps. So all movement is shortening of muscles. They only shorten. And they work in antagonistic pairs so that all movements in the human body or any animal body is a movement of a muscle that stretches another one so we can then contract. Pretty fascinating. Skeletal muscle, conscious control. Cardiac muscle is involuntary control. It is also striated. Here it is on the right. Now, how do you tell it from skeletal muscle? Look for these black lines called intercalated discs. Those are those gap junctions I talked about earlier, which are 2 tubes stuck together that allow calcium ions to transfuse very quickly so that you can get a wave contraction of the heart every 0.85 seconds. It's very rhythmic contraction of the heart. So the cardiac muscle also is more branchy. Look how it's more branchy. See how branched this is? Look like tree roots. And skeletal muscle is a little bit more packed, a little bit more organized, okay? Notice no intercalated disc here. This is 3 cells. This is actually 305 power. And here it is at 750, so we're a little bit closer. And these black lines, this is 1 cell here. Oh, sorry, hit a button, sorry. So these are where 2 cells junctions come together. These are the gap junctions we talked about that allow cell-to-cell communication. So involuntary control, you can't control your heart. Cross striations do exist. We have the stripes. But the intercalated disc is what we want to key on. Look for those little black lines, and you know you're looking at cardiac muscle, or hot dog, as I like to call it. And then smooth muscle lines the guts of the digestive system. Now, this is a really bad picture because it's 495 power, but we'll go to the lab book. Remember, we'll go back that gut slide, and we'll look at those stuff on the outside of the simple columnar. So we'll go right back to that gut slide today in lab and look at it there. This is 400, like I said, 500 power, and it is a stratified cells of smooth muscle, no striations, unconscious control. You can't control peristalsis of pushing the food through your digestive tract. And that is small intestine. A pig is chitlins, right? So a lot of people like to eat that. All right, any questions on muscle? Wouldn't it be a great question about the 3 types, right? Skeletal, smooth, cardiac. And tell me a little bit about those.
I have a question about the cardiac.
Mm-hmm.
So what is the part that makes it contract again? Like what part of it?
We actually talk, Heather, we'll get to that, I promise. Actually, Ms. Nickens will get to that. But what we'll find out is that there are, in the cardiac muscle, they have cells that are self-excitatory. So they have special cells called pacemaker cells that leak calcium in, and they finally reach, and we haven't covered that yet, but an action potential is when a nerve electrical event occurs along a cell membrane where you get an electrical wave that goes down. And so our nervous system works by sending electricity down living electrical lines called neurons, living cell extensions. So it is an electrical event. And cardiac muscle is the only, cardiac muscle and smooth muscle can be self-excitatory. And that's those stomach waves you get. Sometimes you get those rolling stomach, right? And you don't even know what's up with that, you know. So both of these can be self-excitatory. but the cardiac muscle specifically beats on its own. Special cells in it called pacemaker cells. Matter of fact, I used to use this really bad example, but have you ever seen the movie Enter the Dragon, which is considered the greatest kung fu movie ever made? It's Bruce Lee's greatest movie. Y'all know who Bruce Lee is. I think he's a pretty famous martial arts guy in culture and modern folklore. But anyway, but in that great movie, at the end, he gets his enemy and pulls his heart out and shows it to him before he dies. And it's pulsing a little bit. And I know it's anime fake, fake heart. But we really do that when we do a heart transplant, right? We take it out of someone dead, brain dead, but the heart's still working, put it in a cooler, igloo cooler with water on ice, and then we take it and plug it back into somebody else and shock it, and it beats for 20, 30 years more. Actually, I was saying this the other day. I mean, the first ones were done probably in 69, 70. They may be some 10-year-old girl that's like 65, 70 now that's had a heart for 50 years. So the limit is literally we've been doing those since the late 60s, heart transplants. But it's very doable because it's just 4 blood vessels to connect and some nerves, right? So it's not like a brain transplant. We haven't done that yet. But the heart's gotten really good at. But yeah, good point, Heather. It has its own little cells that beat on its own. And that's actually a question in A&P 2. Okay, but which we'll get to in A&P 2. Okay. All right, good point though. So it has its unique little thing. Okay, all right, let's go to the last group here, then we might take a break. We just may just go through and get a little bit in the next chapter. But the nervous tissue, and we're going to learn a little bit different ones in lab. I got just a couple random ones. But nerve tissue comes in mainly 2 main parts here. The neuron is the cell that actually the functional unit of the nervous system. These are long cells that actually carry the electrical impulse I was talking about to Heather on their cell surface. So they're the functional ones that make up the main part of the nervous system. And then these neuroglial cells are support cells that we used to think were like, I hate to say it, but I think about celebrities here. I use too many TV metaphors, but everybody knows these famous people on TV, right? And we got a lot of people that shouldn't be famous that got their own TV show, right? Well, can you imagine, like, if you were to meet, let's say, I don't know, I'm trying to think of somebody Hannah Montana. Y'all know who that is, right? Hannah Montana, right? Miley Cyrus. She probably got a whole entourage for her, right? She got her hair girl, her skin girl. Somebody probably carries her marijuana for her so when she can smoke and not get arrested, right? You know what I'm saying? She's got her own little entourage, okay? Well, when we first started looking at this, let me show you. Here it is. Here's the motor neuron, the big amoeba, and here are all the neuroglial support cells. We thought for a long time these guys might be like star celebrities entourage, which are what? A lot of times these people have so many people on them that literally they're a drain, right? They lose their money because everybody's making money off of them, right? Can you imagine if you won $100 million a day, how many people would come out of the woodwork calling to ask for some money? Right? I mean, could you imagine that? So imagine all these support cells. Well, here's what we now know now. These are not like people support, like leeches of people. These actually have a job. And what it's telling us now is we're going to see in chapter 10, 11, 12, that some or 8 of these we're going to name, these support cells have specific functions. And we think Alzheimer's and other problems of the nervous system are these cells not working right. Okay, which is a big deal, right? Because we're starting to discover what may be called Alzheimer's. So neuroglial cells are support cells of the nervous system. Look at some of the things they do. They anchor the neuron, supply blood to them. A lot of times blood vessels don't go to the brain. They go to these support cells and then they give them their nutrients. They monitor extracellular fluids, speed up nerve impulse transmission, and circulate the fluid surrounding the brain and spinal cord that nurtures and feeds the brain and spinal cord, and may even play a role in helping neurons divide. Or they divide by mitosis because neurons don't divide, excuse me. So anyway, neuroglial cells are still a little bit of mystery left in the brain. Every neuron, though, itself has a cell body, a short extension called dendrites, and usually a long extension called the axon. If you look at this guy right here, I'm not sure. They're calling this the axon right here. But that's usually the extension that carries the electrical impulse away. And these short little bitty ones are the dendrites. And that looks pretty big there. So that, I don't know. But let's just go with it. So we'll call all these others dendrites. And that one long one is the axon. actually can see it in the drawing a little bit better here that they didn't put in here. Never mind. I'm looking for a drawing. Didn't get one. Sorry. So cell body, dendrites, and axons. So in a perfect world, the dendrites receive the electrical impulse. It goes across the cell body, and then the axon carries it on down to the next part. So when you step on a nail, it is an electrical impulse from your toe up your spinal cord, up to your brain. That electricity traveling up is recognized by your brain as, oh, my right toe's got a nail in it. All right, I have a sharp pain down there. And we'll talk more about that. We're going to actually cover nerve transmission in this course. Okay. Last little part on here, just trying to tell. Now look at 3 of these together. Can everybody tell that that's loose connective in A, skeletal muscle here, and simple columnar looking there. So kind of walk through that. And she kind of goes back and remember organs are made out of tissues, right? So you may see all of it. So going back and look at this trachea slide, look at that. Dense irregular, smooth muscle, hyaline cartilage, loose connective, and pseudostratified columnar all on one slide. And that's why epithelium was so tricky, right? Because you can see so much in one slide. Random things here, and they got to end it with some random membranes. Are these layers, thin sheets of epithelium that line and cover our body cavities, right? So we've got a couple of them here. Synovial membrane is our joints. Mucous membranes are those that make mucus. That's the small intestine is a mucous membrane. The reproductive tract is all that. Cutaneous means skin. Serous is a membrane lining the pericardial, peritoneum, and pleural cavities. Okay, just some random terms here. They can produce serous fluid, and that's to keep the lungs from creating friction. So we have that layer of fluid in there. We went over that again. I'm not going to go crazy on that. And then synovial membrane is the knees, the joints of the body that makes synovial fluid that lubricates. So that's all your joints of the body. And here's a cool example of the knee. You can see there is the synovial fluid in the synovial membrane and cartilage rubbing each other, and that fluid lubricates it. Okay, so that's just a membrane of the knee. Synovial means the joints, the whole chapter on joints coming up. And then the cutaneous is skin. We got a whole chapter on skin. And then we've been looking at mucous membranes lining the mouth, the digestive, male and female reproductive system. We mentioned goblet cells. And then we got a chapter coming up next on nothing but skin, the cutaneous membrane. Stratified squamous right there. Dermis, dense irregular down at the bottom. Okay. All right, tissue repair. We'll look at this kind of quick. It really does regenerate. So epithelium does like to regrow. So if you cut yourself, then you'll have fibroblasts come in and lay down some epithelium there, right? And you may have a scar if it goes deep. Here is one a little bit deeper in muscles. So cardiac muscles don't regrow. So you get this fibroblast of irregular connective tissue in here, but we can't regenerate cardiac muscle. It'd be nice if we could grow nice cardiac muscle back in here. So here is damage to a heart attack. And so you end up with scar tissue left in there. Epithelium does like to regrow very quickly, so it heals very well. And it just kind of walking through some of those, nothing much here. Nerves also don't like to regrow. And so you can get these, they just scar tissue in the brain. And that's pretty much all I got on that chapter. All right, if y'all want to take, well, we ain't got about 15, we got about 25 minutes. Let's see if we can get a little bit into, I'll try to stop a little early. I think we're going to be in good shape this week on time-wise. Our next 2 chapters are relatively short. I mean, the next one, our test, keep our story straight. So our test on Friday is going to be 4 and 5. Yes, Sarah.
Sorry, do we have a quiz in lab today?
Yes, we have a quiz today on what? Epithelium, connective stages, mainly connective. Don't hit on this one pretty hard, but I'll sprinkle in some epithelium and some stages.
Okay.
Right, and then tomorrow's quiz will be on muscle and nerve and everything, all the tissues. And so then that's what we're doing. So we're building up to that midterm, right, on Thursday. Now the part that's going to be kind of weird. Now this is the thing that's going to throw you off. Is we're going to do 5. I may go into it for a few minutes here just to get ahead, so we can maybe stop a little bit quicker on Thursday because y'all got that lab test, right? So I would like to stop a little bit early on Thursday, give y'all plenty of time to get up here for a test on Thursday for the lab midterm. But our test on Friday is going to be a relatively short chapter test on 4, which is all we talk about in lab anyway. Philip or me, either one. And then chapter 5. So if we can go a little bit in chapter 5 this morning, I still think I'll stop a little bit early today, maybe 5 minutes early. But you see, if we'd have had that other 20 minutes I lost, we could have probably almost got through this whole thing today. And my intent was to have a relatively light day. Well, I'm gonna have to cover a little bit of chapter 7. Excuse me, get my story straight. Test is on 4 and 5 on Friday, but I'm gonna have to cover 6, like on Wednesday, tomorrow, or whatever day it is. Tuesday and Wednesday, I'm gonna have to lecture a little bit ahead so that we can stay on task. Okay. So hey, I do not like lecturing on the chapters and on the next test. My mind really starts to throw, but I couldn't figure out a better way to do this without having 2 tests on Thursday, right? Which would have been really terrible. Would have been unfair.
Okay, thank you.
Yeah, and I know I'm just trying, okay, because the other thing would be, I don't know, I'll look back at the schedule. The only other thing, today's Tuesday. I got to get my story straight. I wish we could have jammed it and had the test tomorrow, but I just couldn't make it work out. And luckily, I didn't plan on that now that with our power failure and all, or whatever the crap happened. Okay. So let me pull up another PowerPoint real quick. We'll just take a little bit of look at it. Once again, I'm sorry about all the technology mess today. Can't believe that somebody wasn't working on their online homework in my online class. I know they're probably having a stroke today. All right, let me see if I can find it here. I'm having fun with this Zoom today. All right, let's see. Share the screen. Here we go. So we'll just do a little bit. Thank y'all for being patient with me today. Sorry, but let's be sure and write down these. I know it looks like y'all all got it. I'll try to email that back out today. But you can log into Zoom without going through Northwest Internet, right? And I had that, that meeting is already set up, and I was able to start it from Zoom without going through Canvas. So that if we do have that happen again, because anytime there was a thunderstorm in Jackson, somewhere between here and Jackson, several circuits popped. Did they get it working? I think anybody gone in through, Ms. Carr, did you come in through Canvas? Is it working now?
I came in through Canvas and it was fine for me.
They got it working. Okay. So like I said, sorry about that. Yeah, it got us about a 20-minute delay. I am taping this thing, so I'll put it on there. I'll put it back up. All right. Can y'all see that one? Okay. Okay. So thanks, Heather. All right. So this is actually a relatively short chapter. Once again, I would say that I know we got a lot going on Thursday, but y'all need to blow this on Friday away. So we'll come in and y'all should have an hour on Friday. Shouldn't take more than an hour. I think an hour and 15 minutes. We are going to have our first picture on a test. Let's do this. Let's get that out of the way. Let me see if I can get it to come up. So we will have to label some skin like this. So we are going to label skin. So I'm not saying it's going to be this exact picture, so don't memorize the sequence of things, but it will be very similar to this. You'll have these. Now watch this. This is really weird. Your books like to say that there are 2 layers of skin. The epidermis, which is we already talked about that, stratified squamous, and then the dermis, which is dense irregular with some stuff in it, glands and stuff in it. But then there's a layer under the dermis called the hypodermis. And it gets really weird. So some people consider it part of the skin. Miss Ammerman doesn't, but then she turns right around and makes you label it right under it. Now, I can tell you, you've all seen this before. The hypodermis is the boundary between the dermis and this subcutaneous layer. And this is also where you get a tear on stretch marks. So if you've ever gained a lot of weight, lost a lot of weight, I've done that. I told you I've got down to 150 twice. So I have some stretch marks in my stomach. You ladies, when y'all have babies, a lot of women get stretch marks, right? Due to stretching some of the skin. So a stretch mark is a tear between the dermis and the hypodermis. Okay? Now, some of y'all have 5 kids and never have stretch marks. So a lot of it's got to do with just random genetic luck or whatever, okay? But let me point out something really bizarre here. A lot of y'all are going to go spend a lot of money at drugstores buying stuff to make stretch marks go away. Let me just make this very clear. There's nothing you can buy in a store in North America that will go through this layer all the way down to here and heal that. That's called snake oil. That's called shaman, not true, fake products. Okay. And as we get into this chapter, I will get on my soapbox, and y'all forgive me because I buy Grizzly tickets, so I am the world's best at wasting money. Okay. I've spent a fortune over the last 20 years buying tickets to the Grizzlies. I could have a swimming pool. I could have probably went to Hawaii 10 or 15 times. So we all choose to waste our money in America as we choose to. But I'm going to get really ugly. I'm going to be kind of rough on you girls and guys that spend a lot of money wasting things on your hair and skin that are doing no good. Okay. And here's one of them. There is nothing chemical. There are chemicals that will penetrate down here, but they will probably kill you or destroy your skin completely. Okay. I actually used one of these in lab. We used a chemical called DMSO, which is a solvent. When I was telling you I did research on these herbicides and pesticides to see if they would hurt reproductive system, we would use this chemical to dissolve anything. And one time my professor showed me something crazy. We always wore gloves with it. He took a textbook, a real old textbook, like one of these big books I got here like this, like a real book. He put a drop of this on Friday, and we came back, the table was wet on Monday. So it penetrated the entire book. Yeah. Have you ever seen veterinarians with a horse that can't move, and right before the horse dies, or at the last resort, is they'll rub this on the knee and it'll dissolve all the ligament damage and the ligaments themselves and probably get 1 or 2 more races out of that horse before it can't stand. So this is used sometimes, I think, in abuse of specifically race horses and show horses to kind of help fix their joints. But it don't fix them, it just dissolves them. Okay? So don't put, and I know a girl that used this on her skin because she thought it made her look beautiful. Straighten out all them wrinkles, it burn a hole clean through it all. So be careful with that. Okay, so the 3 layers are epidermis, dermis, and subcutaneous, or hypodermis. Notice it's a layer of fat. So there's a layer of fat between the dermis and the hypodermis, and that is where stretch marks occurs. Now look at some structures in here. Here's a sweat gland, here and here. Here are some nerve endings. We have more nerve endings in the skin than anywhere else in the body. Here is a hair cell with a sebaceous gland that makes the oil, that makes our hair oily. Here's a muscle. There's a muscle associated with every hair follicle called the rector pillar muscle that contracts. This one makes your hair stand up. Now I know, y'all, everybody remember Little Rascals, right? Spanky and all them, right? You know, the time Spanky gets scared, they make his hair stand straight up. That does not happen in humans. But cats and stuff do have more erector pillar muscles. So you do get goosebumps when you get scared or excited, right? And that's the erector pillar muscles contracting. Okay. But cats can really make the hair on the back of their neck really stand up. They have a little bit more response to that. But that's the erector pillar muscle. Here are a cool receptor we're going to look at in lab today called laminated. This is called Pacinian corpuscle. Looks like a fingerprint. And that is, there's a difference between, look, this and this. When Mama pinched you in church, that was the lamellated or Pacinian corpuscle. And when somebody lightly touches you, it's right out here with these other receptors called myostrum corpuscles that are right on the edge of the skin. So light touch, pressure, handcuffs, pinched at church. Sound vibrations can be felt in the skin with those. Blood vessels are rich down here, but remember there's no blood vessels. Epidermis is avascular, but blood vessels are all up in the dermis. Okay. Any questions on those? Something like, I don't think it's that picture. I may have used one out of the lab book, but we will have a picture very similar to this for you to label. Sweat pores on the top, that's where the sweat comes out. Okay, and the oil coming out with the hair. Everybody follow that. Now this is on the test Friday on chapters 4 and 5, which we're going to have Friday. Okay. All right. And here's some of those accessory organs, right? We already mentioned them. Rector pillar muscle, avascular epidermis, right? We already mentioned that. Look at that, 50% of epidermal cells are too far from the adequate blood supply, and then they eventually die and form that dead flaky layer on the outside. Right here, you can see it right here, from here up. And we're going to blow it up in just a minute and look at it in a little more detail. That hypodermis at the bottom, also called layer of fat, right? It's not part of the skin, but it anchors the skin to the rest of the body. So we'll go with that. Blood vessels and skin, mainly. Excuse me, blood vessels and adipose. All right, here's a fun one to talk about. How many of y'all have dealt with cellulite, right? Little dimples or orange peel appearance of skin when collagen bands form around adipose tissue in the hypodermis. Develops in the thighs, hips, and gluteal areas. And look at this. It is not a disorder. It's a normal condition that is affected by genetics, gender, and how much adipose you have in your age. Very little can be done to cure it. So in other words, you can't buy any chemicals, really fix it. To minimize it, eat right and regular exercise, but that still doesn't keep you from getting these cellulite. Okay? So you can be workout queen and still get cellulite. Okay, the main function of the skin, the integumentary system, is to protect the body. It's its main role, first line defense, mechanical trauma, pathogens, environment. I mean, think about it. COVID-19, it's got to penetrate the epithelium somewhere, right? Probably in the simple squamous epithelium lining the air passageway, right? You breathe it in, it gets down in there. Bacterial infections, all that. Food poisoning gets to the simple colon. So skin is all about outside protection. Continuous barrier, invaders, microorganisms, pathogens, right? Super important. It has those glands that can secrete antimicrobial substances, right? To change the pH of the skin. We can tan to prevent what? Ultraviolet radiant light that causes skin cancer, right? And we even make some of these secrete hydrophobic lipid-based chemicals, repel salts, polar covalent molecules, et cetera, et cetera. So all about protection. And sensation. The most nerve receptors are in the skin. So this is where we get most of our sensations of touch, feel, heat, pressure, cold, pain. All those receptors are in the skin. Thermoregulation, super important here, plays a role in that. If we get too hot, we can release the sweat that helps cool the body. That's a big deal. Plays a big role with the heat and cold receptors. Okay, huge role in that. When we get hot, look what happens. When the temperature gets too hot, then we push blood to our skin to let the hot blood, let the heat leave by radiant heat exchange. I think one of the most funniest things that a lot of people don't realize is after you go to the gym and work out for an hour, have you noticed your pants don't fit? You're puffy because that's the blood is being pushed to your skin. So you have not gained 10 pounds. You probably lost 2 or 3 pounds, but your body pushes the blood to the skin to cool the body. And when you get real cold, which is the flip of that, we cut this blood flow off to the skin and you get pale or gothic looking, right? One of the times we used to take her when our children were little, especially the oldest, she probably went to Disney World about 6 times and her little sister only went about 3 times. So we kind of quit going. But one time we went down there and we were staying at one of the ones that had a big old pool shaped like, I don't know, Mickey Mouse or something, I forget. But it was probably about 70 degrees down there in spring. We'd go spring break because my wife taught kindergarten and I taught Air Northwest. And we were down there and I could see the steam coming off the pool. So the pool was heated, but I kept lying to my little oldest daughter. She was probably about 7 or 8. And she finally, on like the next to last night, she goes, "Daddy, please, let's go get in the pool." We don't have a pool at home because I have a Grizzly tickets, no swimming pool. And so I get in the pool with her, but I find the vent where the water's coming in hot. So I just sat by the vent, let her play in the waterfall or whatever. And all of a sudden, after about 40 minutes, I'm thinking like, let me check on my daughter or something. I'm kind of halfway watching her. And I look at her and she is purple around the lips and she's shaking. She's near hypothermia because she probably weighed, 30, 40 pounds soaking wet, little bitty thing. And she's been in this 75-degree water, or maybe it's 80. It was pretty cold. And literally was shaking. So I had to get her out, put her in a hot bathtub and put some clothes on her, right? She literally was shaking. So hypothermia, she looked blue. She got the blue look because the blood pulls off the skin and you'll turn kind of pale or blue looking. All of that's a great example of homeostatic mechanism, right? If we get cold, we cut the blood off to the skin. If we get hot, we send it to the skin and we do we sweat to get rid of the release the hot fluid. A really good example of homeostasis there. Okay. And of course, we do excrete some waste products in our skin, in the sweat. Of course, our kidneys play a bigger role in that. We also can make vitamin D in our skin, so it is good to get sunlight. You need some sunlight. A lot of people don't realize that, but it is very important to get sunlight. Living in a cave is not necessarily good. We do make vitamin D that way. Okay, now we're going to look at the layers of the skin real quick. The outer layers, that epidermis we already talked about. Well, these keratinocyte cells make up 95% of the epidermis with that thick outer covering. And we also have this keratin, a tough protein outer layer that is a big protective mechanical prevent against mechanical trauma. Okay, under that stratum basum is the lowest layer of it. Let's actually look at a picture of this. So here's another one. We're going to label this, I think, on Friday also. These are the layers of the epidermis. Take a look. We'll start at the very inside. Here's the stratum basal. That is the edge of the epithelium. The interregular connected below it. And then look, stratum spinosum, stratum lucidium. Only that's a shiny little layer only found in thick skin. And then stratum corneum, that's the dead flaky layer that forms dandruff or that we flick off. So, and the nerve endings are right in here. That looks like a nerve ending right there. So you got to push really hard to feel something touching you. I always think about, you ever notice like seeing a fly lay on your arm and just walk across and you didn't feel it? Or you see it walking on somebody else? It's got to have enough weight to push down to fire a touch receptor, and a fly don't. So be able to label this layer of the epidermis on Friday. Here's it talks about many of the topical medications, the antibiotics we put on our skin to keep us from getting infected. You do not want to lick these or eat these. Many of these are toxins or poisons and maybe even heavy metals to help kill pathogens on the skin. So don't be licking each other. Bad idea to lick each other. Licking, not good. Especially if you got drugs on your body. Okay? Here's a way to learn it. The different layers. They like to use these little, I don't know what they call these little songs here. Brilliant studying gives loads of confidence. That's labeling the different layers of the basal, stratum spinosum, granulosum, lucidium, and corneum. Okay, that brings us to a corn, right? When it overgrows with that, you can have a growth on your bottom of your foot or specifically feet. Really common. These keratinocyte cells live for 40 to 60 days and then they die. They're continuously being replaced. So we're always growing skin. Skin is one of the best at regrowth of any of our body parts. Skin's always regrowing. Here's some of the cells in the skin. These mercurial cells or sensory receptors, melanocytes that make the skin pigmentation, melanin that gives our skin its color. We're going to look at it tomorrow in here. We'll talk quite a bit about that. And then the thickness, where do you think the thickest skin is in your body? It is the hands and the palms of your feet, palms and heels of the feet. The thinnest would probably be along the arms, etc. So thin skin like in the arms, for places we don't ever rub, are thin. So it varies from place to place. I think I told my A&P lecture labs that when I taught this for 29 years here, probably for up until we moved this building and got these microscopes and I took pictures, I actually had a carousel of pictures, and I would do 16 different pictures of skin that none of them looked the same to start this lecture off, just to kind of mess with people to get them to try to find these tissues. And I think y'all catching on. Epithelium has got to be on an edge, right? And I would show stratified squamous 16 times. I had all kind of slides of skin. Thick skin, thin skin, all over the body. Look at that. Thick skin can be as thick as a paper towel. So your palms and bottom of your feet are paper towel thick, and thin skin can be about the size of printer paper, so much thinner. Okay, and calluses are additional layers of stratum corneum due to repetitive touching that part. So wherever you rub your skin, you will get more growth, and that can be painful calluses on your feet. There we go. Here's a slide. There's thick skin on the left. That would probably be the palms of the hands or feet, and thin skin on the right, maybe in the arm or something like that. Okay, I think let's just stop here. It's a good stopping point. We'll stop a few minutes early. Sorry about this lecture today. Kind of crazy. Luckily, it wasn't a very I don't think difficult one. I'll get it converted over. Does anybody have a question about this week? We've got a lot going on this week. Do I need to pull the schedule out real quick? We'll pull up a schedule to kind of prep ourselves on the week. I think we got it right. I mean, everybody knows, right? We'll finish 5 tomorrow, maybe go into 6. And then on Thursday, I'll try to lecture very little, okay, Thursday. Maybe we may just have an hour lecture on Thursday to give y'all time to come up here and prepare for the midterm test. I will do this. If the late group wants to come on in here and get over with, I'm fine with that. So we might start at 11 as we're supposed to. But if the other group wants to come around 12:30, we could probably just knock it out real quick. I have 2 or 3 versions of that test, but the midterm should go pretty quick. With us just having 9, we'll take it in one group. But we'll talk about it this afternoon. But I think the later lab could come on in a little early. We get on out of here on Thursday, give y'all a little time to go home and study for this lecture test on Friday. I'm fine with that. Or we can start at 1, whatever. I mean, it doesn't matter to me. But I don't think we need to. I'm not going to be 2 hours giving that test to the first group. Let's put that away. So if y'all want to come on in or hang around, come on over a little early and knock this thing out, we can do that. We'll talk about it today. Any questions, anybody? Any thoughts? All right, y'all get on out of here. I'll see y'all up here at lab. Today's lab is on, we're looking at connective tissues, right? A lot easier than the other day. Epithelium was very difficult. So connective today, muscle and nerve tomorrow, midterm on Thursday. Wow, this goes fast. All right, see y'all. Sorry about the technology problem. Be sure and tape these down. And if Canvas ain't working, we'll just go to Zoom on our own, okay? See y'all later. I'll hang on if y'all got any questions. Hang on if you got anything major. Sorry about that, Hayden. Sorry, I didn't know. I was trying to get in here, dude. But you caught us for plenty of time. Anybody else? Molly, you okay?
I have a question about the test Friday.
Test Friday. Okay, what's up?
Okay, so is it what we just covered on chapter 4 and then what we're going to cover the rest of 5 tomorrow?
Yep.
Okay, I just wanted to make sure.
Yeah, so that test is 4 and 5. I would have loved to have it tomorrow, but thank goodness we didn't try to jam it, right? Because we didn't have time to finish. I could have almost done it if it hadn't been for the technology stuff, but I really didn't think of it. I thought it'd been really hard to get it in Wednesday. So we'll just kind of back off a little bit and get through the midterm in lab, and then we'll have that test on Friday.
Okay.
Chaney, what's up? Question? You good?
I had a question.
Shoot, fire away.
Okay, so Canvas is still not working for me. Did they ever get back to you?
They said they was working on it. So, and I think Rosalind, Miss Barr got in there that way. I can check real quick. Let's see if it's working. Hang on.
Yeah, it's not working like on the laptop, but you can do it like on a phone or whatever. You can get to it like on the phone, but as far as going to the laptop and like doing the homework or whatever, it's not working.
Okay, should have done. It was working last night, wasn't it? So they'll have it back on today. We'll see if they don't get it back working. I don't know what we got due today, but I don't think we got. Probably don't have a whole lot
Nothing's
due
due today, but chapter 4, the stuff for chapter 4 is due tomorrow.
Okay.
That's why I said something.
Well, if it ain't on by 10 o'clock, if they don't get it working by this afternoon, we'll move it. But in the meantime, wait, you keep checking it because I don't want to move deadlines, guys. Because let's don't wait the last minute, okay? Okay, I guess. But anyway, but if it don't work, I'll give you some more time. But that's just a big pain in my butt. But if it's out all day, I'm not gonna move it. Okay, that's fair enough.
You can access the mastering homework through the app.
Through the app.
I tried to do that and it won't take me there. Like the only way I can get there is through Canvas. But I had a question about the mastering homework from last week.
What about it?
It said on there that you put a 0 in from the homework, but I
haven't put any zeros in anything. It automatically does that. Okay, if you don't.
Okay, that
if you didn't get it in by the deadline, it's going to be a 0. And I told some of y'all I'd go back and look at it, but I'm just not gonna. I owe a couple of people that had trouble the first week, but.
That's where mine's in. Mine's in from the first week as a 0.
It's going to be 0 to I get in there and look at it. And I hadn't gone in and looked at it. Hadn't had a chance.
Okay, awesome. It kind of freaked me out, so I didn't know what was going on.
And it doesn't transfer automatically. Because when you go to the mastering homework, you're not in Canvas. You're in Pearson Taiwan somewhere, right?
Right. So it's like it gave me hundreds on the actual thing, and then at the top it says 0. So I just wanted to check in and make sure I didn't do it.
Sure you're in the right area.
Sir?
Are you logging in? You're in the My Mastering homework. Make sure you're not in the study area, right? Are you sure
Okay.
you're in the right area doing it? I just have to look, okay? But you need,
Okay, yes, sir.
but you can go through it without, you can go to it, what Hayden is saying, you can go there without going through Blackboard, okay? Through Canvas.
Okay, can I come see you after lab and you show me that? Cause I'm kind of confused on that.
Okay. Well, I don't go through it the other way either. I'm gonna have to get Hayden to show you in lab. Okay. Honestly,
Okay.
I just go through Canvas.
Okay, thank you.
But it ain't been down. But I don't think it was down last night. One of y'all had a stroke because I'm sure someone worked on it last night. So it went down during that storm during the middle of the night. Okay, but I bet it's back up, and I'll check it before lab. We'll try to see if it's working in lab. Okay.
Yes, sir. Thank you.
Okay, no problem. Hang in there. And I told you I'd go back for the first couple that y'all were having trouble with. But I'm not going to go forward, doing it unless there's a real technical problem. It's like knocks us out most of the day. Okay.
Yes, sir.
I'll be fair. I promise I'll be fair. But no, I don't have any. I haven't went back and checked anybody's stuff. So if you did it late, yeah, you got 0. But I told you I'd go back and look at it. I will.
Okay, yes, sir. I didn't do it late or anything. It just made me nervous. I just wanted to check.
All right. Well, I'll go back in there and look. It should be in there. You may be doing it wrong because it should automatically put it in there unless you missed the deadline. Did you miss the first deadline, Molly? You think?
No, sir. I did it as we went through the thing. As we went through each chapter, I would go that night and do it.
Okay. Well, it should be in Canvas. Okay. I'll go in there and look. I'll go look real quick while y'all driving up here. Okay. So get on out of here. Don't be late. Which one you got? Which one you in, Molly?
For lab,
Yeah.
Carrera. I'm
Okay.
in his first class this morning.
I will get on up here. I'll look at it. I'll try to look. Okay.
Okay. Yes, sir. Thank you.
Thanks. No problem. Hayden, a question?
Yes, I was going to ask, have you happened to grade the test yet?
Yes. And I haven't had time to put them up because I've been dealing with this technology crap. I'll try
Yes.
to put them up in a minute.
I was going to say, would I be able to come down and see my grade or?
I'm going to post them, but let's just look at them on Friday. Okay.
Yes, sir.
Is that okay? Because if don't, everybody's going to want to come in here. I won't be able to get no lunch.
Yes, sir.
It's okay, but I will do like we did Friday. I think that worked pretty good. I'm going to post them right now, and then I'll let you. Is that okay? Then you can come by and look at them on Friday. We'll just let everybody look at them after
Yes,
the test.
Yes, sir.
Okay? Because I don't put any of that on the file anyway. So really, it's just a matter of checking to make sure I didn't make an error, which I'm fine with that. I'm fine with y'all looking at them. Okay?
Yes, sir.
All right. See you in a minute. See you in just a minute.
Yes,
Let me
sir.
see if this stuff is working. Sorry.